But before we start with the actual talk, I would like to talk a little bit about different business model that we have. So we are not a SaaS company. We don't sell software to real estate agents. We offer a full service property management for $100. That's the service that we offer. Currently, we are offering this service in East Coast Australia. Basically, we've been in production for a little bit more than 2 years. And the company is called Different mainly because the approach to property management for us is quite different from other real estate agents. That is how a tech company started looking at property management and ended up actually revisiting the whole idea behind property management. Traditionally, if you look at a property manager, what happens is that you sign a contract with a real estate agent, and that real estate agent gives you a property manager, somebody that will look after your property from a different aspects of it. It helps you to lease the property. It does the ongoing inspections and anything else. At Different, our approach is a team-based approach, which means that there are multiple teams that will look after different aspects of your property. For example, if you need to find a new tenant for your property, basically the leasing team will look after that one. And if you need to basically fix something in your property, for example, a dishwasher is broken, there is a maintenance team will look after your property. So that's why in general the company is called Different, mainly because of the approach. But also, the service that we are offering to our tenants, to our property owners, is quite different from other companies. Not that it is cheaper, in my opinion, it is better, and it is on top of technology. So a lot of things that happens in other companies in a manual process, for example, signing a lease agreement or paying your rent or requesting for a document, often that happens through email. In our platform, there is mobile applications, web applications, that information is available to you. And if there is any problem, you can reach out to us at any time using our platform. But also, then you will receive live updates about the updates on your task. For example, if there's a maintenance request, you will get notification as soon as we assign a tradie and we book a time for tradie to come to your place and, for example, fix your dishwasher. So that's why the company is called Different. As I mentioned, it's a tech company. It's not a real estate agent. We just basically disrupting the real estate industry. So that's a little bit about what we do at Different. And also, this is not my company. I work for that company. The journey of Different started with our founders helping their parents with their investment properties. Basically, their parents had some investment properties in Melbourne, and they were trying to understand that what's happening exactly under the hood. They were trying to understand why they are paying that rate for property manager and what kind of services they are getting in return. And unfortunately, they couldn't answer those questions, and they realized that there's opportunity there for them to basically launch a service. And fast forward, today we are offering our service in East Coast Australia. And that's exactly what happens in many startups. You have an idea and suddenly you are live, and before you realize you got the traction from your customers and you keep building new features without thinking actually what's happening. So this is a story of many startups, including Different, which is a very happy story. That's what you want to basically hear, is that, hey, we got the customers and we are selling our product. So that is very good. Looking back like 2 years ago, that is the architecture of our platform, roughly. There is a database, MySQL database on the top, and we have in front of it a bunch of services. They are not necessarily REST APIs, but they are exposed to internet using HTTP protocol. And in front of those APIs are our client-facing applications. For example, we had an app for web application for owners to see information of their properties. And we had another web application for admins, for our colleagues in different offices to deal with the basically property management, we had native applications that were basically in use by some of our colleagues, as well as a tenant app for our tenants. As you can see, basically tenant app had its own API, and internal applications for our admins, they had their own API, and admin and owner web applications, they were using another API. And you can see that I put some screens, little screens in under each API. What that means, those are, think of them, those are as endpoints. They were not necessarily REST endpoints, they were endpoints built for a screen. So there was one endpoint that's serving a statistics data for a given screen in owner app, for example. So that was the nature of those basically endpoints, and that's the architecture of platform at that time. And obviously on top of everything is our database. So we had a couple of problems there, and there was time for us to address those problems. The reason is that those technical debts, they were very critical, and they started slowing us down, and we couldn't build the features that we wanted with the speed that the business needed. So there are lots of technical debts for a startup, that's no surprise, but there were two categories of technical debts that I wanted to focus on today. One is that related to our database. So what was the problem? Usually UI represents database. So can be a web application, mobile application, whatever you can think of it. But we don't often see database represents the UI. In our case, our database was a representation of the UI. Let me explain to you with example. You could look at a table and in one side and put a screen, like a web application screen on the other side, and see that they relate to each other. The way the data was stored in that table, the table name, the column names, the type of the basically data, and what was stored in a given table was mapping to a screen, not necessarily how that piece of information should be stored in a database. As a result of it, we had information about owner that was inside property table. Why? Because we were capturing that information when we were adding a property. But not necessarily because that information belongs to a property. So that was the type of problem that we were dealing with. Basically, we had another problem that was, we had a core data that we were capturing from properties, leases, owners, tenants, and we had a UI related data. For example, UI related data can be as simple as, if I want to see a dark mode of this web application or a light mode of it. These two information, they were stored side by side in the same table, in the same data set. And it wasn't clear that what is a core data set that we have and what is the UI. And often we were refactoring the UI, removing those features, and the data was, the column and all data was still in database. And everything, almost everything in our database was nullable. The reason why it was like that, because the database was following the UI. So the architecture of data. So you see that almost any column in the database, except if it's a primary key, was nullable. Whereas you could see that under no circumstances that field could be nullable unless you just follow a UI. That in most scenarios, it wasn't there anymore. And the many problems that we have, one of them was that actually we had one-on-one relationships, and they were represented in our system as a table. For example, a property has a owner, and let's say that one property has one single owner. So you can store the property owner next to the property information. In our system, it was stored in another table. We had these kind of challenges. And as a result of it, you could, if you wanted to fetch a simple set of data about the property, you had to involve a couple of tables, do a couple of joins, and to get the data. So it wasn't necessarily easy to query our data. And it wasn't easy to understand how the data is being stored in our database, how we're gonna use it, under what circumstances it is null, and under what circumstances it has a value. And that was the type of problems that we were dealing with. The second part of the problems that we were dealing with was in the API layer, in that HTTP-based APIs. these endpoints that we had, and believe me, we had many of them. We are talking about, for a small startup, for more than 100 endpoints. And these endpoints were tailored for one single use case. One endpoint with weird names for serving properties for admin, one for serving properties for owner, and the other one was for the statistics. We had all sort of basically endpoints, each of them tailored for one single use case. And as a result of it, we had data inconsistencies across the board. For example, if we are looking at a lease, saying that what is the next payment for this lease? One endpoint would return the correct number and the other endpoint would return the wrong number. The reason is that if we change the logic of calculation and calculation happens on the fly, it's applied in one place, it's not applied in another place, or they have a different logic. So we had those kind of problems that the data inconsistencies was showing up in our apps. Tenant was saying that why my rent is this amount, and in admin was another amount as well. So that was another problem. And obviously we had a manual and outdated API documentation all the time. So because there wasn't any way to generate it for that specific build, the documentation was usually outdated. And whenever we wanted to give this documentation to the mobile engineers, the front-end engineers, it was outdated. They had to read the code to understand it. And we couldn't actually repurpose these endpoints. We couldn't reuse them. If we wanted to build a new feature, often we had to start building some endpoints for them to fetch the data. That was the basically the way we were doing. So these are kind of two set of problems that we had. At some point, we decided that this is not going to work. Among other things that we wanted to have in our platform, for example, following a TDD, having proper test coverage for our platform, we had a set of goals that we wanted to address and we wanted to achieve at some point. We wanted to restructure our database. We wanted our data be stored in a way that it makes sense and it is maintainable, and basically it scales as the business is scaling and we get more customers. We wanted to have an API that is reusable, it's extendable, and it's a client agnostic. We can use it with any client, and it is something that we can extend it at any time and we can reuse it. The reason why is that we were a startup. We wanted to build once and use it 100 times. We just didn't have enough engineers to keep rebuilding things. So that was the goal for us. And we wanted to have an abstract layer on top of our databases. We didn't want everybody in our platform to connect to the database and to integrate with every piece of basically logic that we have, every piece of data that we have in a database. We wanted to have an abstract layer that sits in front of our databases, and whoever wants to have access to our data should go through that layer. And we were looking for a solution that allows us to have a transition from the existing architecture to the new architecture in a basically period of time. We could not afford to basically stop everything and rewrite our API. That was impossible. We had a huge backlog of features to build and we had to keep building it. So that was basically another challenge for us. So came a lot of solutions that we looked into it. One was GraphQL, and why GraphQL was a perfect match for us at that point. The first one was that by nature, GraphQL server is client agnostic. You can consume that one by a web application, a mobile application, and you can consume a GraphQL basically service using a backend service. That was ideal for us. And we could build a reusable graph of data. We were not looking for serving specific customers. We were looking for something that we can represent our data in a model of a graph, and something that can be reused. We wanted to define relationships. We wanted to define models of filtering, something that people can just put together in a way that they want and fetch our data. And GraphQL could be the abstract layer for us, right? It's the query language is very interesting, and we could put GraphQL in front of our basically client application and other backend applications and let them consume our data using GraphQL rather than hitting database. And why we wanted this abstract layer obviously was that we wanted to refactor the database. until people connecting to the database and integrating with the database directly, we cannot change the code because it's going to break things. So we should stop integrating with the database directly. But to doing that one, well, we need to have an abstract layer that talks to the client, and from the other side, it talks to that legacy application or legacy database. So GraphQL was offering that abstract layer for us as well. And one thing that we wanted to figure out was that comes with the good tooling in terms of documentation. And GraphQL comes with lots of good tooling for documentation, and it comes for free. We just annotate our types, and that's it. It's available. And considering that the team was growing and people would keep adding new stuff to GraphQL, we wanted a way to easily just explore the API and see what's happening and what sort of data we have. So that was a really good win for us, and we didn't need to do anything to understand what type of fields we have for each given type and how it works. And the last thing that was the most important thing for us was that GraphQL is extendable. We could start very small and keep introducing new things. And that was great for us. So we could actually launch the very first version of our GraphQL API in 2-3 weeks if we had a very small scope. So these are really the main reasons of why we picked GraphQL as a basically a solution for our problem. So what's the current state of GraphQL at Different is that we are in production for over a year now. We have front-end applications, back-end applications, and mobile applications using it. Some of our basically apps are fully built on top of this GraphQL API. Some of them are still hitting legacy applications, but as we introduce new fields to our GraphQL and new set of data, they can migrate faster. And the graph of our data is keep growing, and it actually scales very well. Like as if the company is becoming mature, we capture more data and we want to expose that one to different applications. For some reason, GraphQL works very well with that one. We really like that approach of basically extending the graph and still being manageable under the hood. And as I mentioned, we have basically launched an entirely new application without writing a single line of code for the backend. So we reuse anything that we had for that application, and it was purely front-end development, whereas in the past we had to build all sort of basically logic for the backend to fetch data to do authentication. So that was basically a good thing for us. And it's really extendable, as I mentioned. We keep introducing new types, new features, existing types are extended, and we don't break anything. And that's just because the nature of GraphQL is that you can always start small and keep adding things to it later on. So that's the current state of our basically GraphQL server. What is the architecture of Different today? You can see that GraphQL is in the core part of our platform. It is the abstraction layer to fetch data and manipulate it. We have backend systems in our platform. For example, we have a queue system that requires some sort of data. It uses GraphQL to fetch those data, to manipulate those data. We have front-end applications written in React. Basically, they work just fine, as well as the backend applications. This GraphQL, this implementation allows us to basically expose our API to the third parties, to our partners, for the companies who want to build a solution on top of our solution. And that just works out of the box without doing any extra work. In fact, we do a lot of debuggings. Like when something goes wrong, we look at the GraphQL and query our data using GraphQL rather than going to our databases as an engineer. So GraphQL is something that we use as engineers and other team members. They query the data that they need to using that one as well. And on top of that, you can see that we already have another database, and GraphQL is basically proxy in front of our MongoDB, MySQL, S3, for example, or even we have third-party APIs that we consume their data and inject it to our platform using GraphQL. So that is how basically this project is helping us. we have started the transition from the legacy database to the new database, and that works just fine. We have started introducing features that allows us to store UI specific data in a data storage, not necessarily next to the core data set that we have using GraphQL. And we can run migration scripts, migrate our data to the new versions, and without being worried to break any client, because we can introduce this kind of logic into GraphQL and basically at some point shift from version 1 to version 2 of a data set without causing any issue. In fact, we have built features that are built on top of the existing database, but using GraphQL. As soon as we change the database to the new system, basically, we expect that everything continues to work without any issue, because those applications, front end and back end, have no idea about where the data comes from. They just talk to GraphQL. So that is kind of the architecture right now. Throughout our journey, we learned a lot of things, and I would like to share a couple of them with you as a takeaways. The first thing is that GraphQL is really extendable. You can start small and extend it. In this example, this is actually what we've done. We needed a list of properties, and for each property, we needed ID and address of that property. And that was what we exactly introduced to GraphQL. We didn't say that, oh, this property belongs to this jurisdiction, this property has owners, and all sort of information. We did not need them at that point. So we started very small, and we introduced a type called lease, and then we introduced a relationship between property and lease. And all of this happened without breaking anything. So if you are planning to build a project using GraphQL, start small, because it just gives you the outcome faster, and you can evaluate, and always you can introduce new things, and it just works fine. One of the mistakes that we had was we overuse GraphQL types. One of the benefits of something like GraphQL is the typing system that allows you to basically define the shape of your data. But sometimes you can overuse that one. And overusing types is something that you can do with anything that offers typing system. Any type programming language, you can overuse that one. You can see that in the left side of the screen, we have a mutation field called update. And basically, it receives a single argument, which is an object of a type that we never reuse. So yes, we define a new type here, and we accept everything using that type. On the right-hand side is a similar mutation for updating or adding, and you can see that there is a root level arguments. Why these are same and it's simpler on the right is just because we leverage GraphQL built-in features rather than introducing a new type. So typing in general is cool, but I think that sometimes we can overuse it. So just be aware that sometimes it's doesn't solve any problem by introducing a new type to GraphQL, but rather leverage the existing primitive data types that GraphQL comes with it. And the next one was that basically GraphQL, because you have no idea that what sort of information the user is asking for, you can't really plan ahead of time for optimization while building that service till you actually have the query. So in this example, you see on the left that we are asking for the active properties in our system. For each of those active properties, we want to know what is the active lease for that given property. And for that lease, we want to know who are the tenants for that basically lease. We have three sets of information. We need properties, and after that we can resolve leases, and after that we can resolve tenants. We can actually basically batch these queries, and I highly recommend to looking at that one, because if we don't batch these queries, we could send 2,000 requests to the database, and for a company like in our size even can basically cause performance issues. So one of the things that we looked into is that how we can introduce batching data retrieval logic in our implementation. And so it basically improves the performance as well, something that you definitely need to look into it as well. A couple of other things that we didn't necessarily deal with it because then due to nature of our business, but this is something that you may want to know about it. One is caching. The caching strategy for a GraphQL server is quite different from, for example, a REST service. For a REST service, you know that what you are returning, and you can just do caching based on the URL in most scenarios. In GraphQL, it's mostly about the query, and the query varies from one request to another request. So you need to rethink about caching, and if you need caching in place. Luckily, we don't need caching at this stage in our platform, so we didn't really go deep to solving this problem. The second thing is that if in your use case, you, for some reason, need to have a macro services for your backend. And if you have multiple services, the way of you can think about macro GraphQL services is different from the way you traditionally think about REST APIs, for example, how you split them into multiple services. Because again, it's the single query that comes to the server. And at that point, you need to decide that how you resolve this query. So it involves some more work as well. So that's something that if you think that you need it at some point, you better think about upfront. And rate limiting is another thing. Again, when it comes to a REST endpoint, you know that per request, you can just rate limit. But with GraphQL, really, the request doesn't matter. What the user is fetching matters. So rate limiting is not about the number of requests, it's about what user wants from us. And so there's a different concept of rate limiting applies to GraphQL servers. Is something that you need to think about it. For example, on the left side, I have put things that are, we want to know active properties. It's super simple to fetch this query. It's not difficult at all. And for each of them, I want to know what is the active list. It's very easy, again, to fetch it, as well as the tenants. We send 3 requests to the server maximum and fetch all of them, and it's super fast, even if you ask 2,000 properties, and if each of them have 1 active lease and each of them have 2 tenants. But what is really difficult is paid to date for a lease, because it involves a lot of calculation. So that single field is actually very expensive to calculate. So if we are doing rate limiting, that to this level, we need to be concerned about what user is asking and if it is expensive to do that one or not. Which comes to the next point is that with the REST APIs, often you don't have a concept of query complexity because you know what user wants. That's the server dictating what will be returned to the user in most scenarios, unless you have some sort of filtering. Even with the filtering, it's a limited number of filtering options. With GraphQL, you have no clue what user is asking. They can just write a gigantic query and fetch all of your data set. Then the server should understand that how complex is this query. Then the complexity comes to the fields, to the subfields, to the pagination and sort of stuff. So this is something that you need to look into it if query complexity is something that in future can be source of an issue for you, especially if you are releasing this GraphQL API to users in a public manner. That's the time that you gotta look at caching, rate limiting, and query complexity. For us, because at the moment we don't have public-facing customers, all of them are internal customers, we haven't really dig into these topics, but we know that these are something that when we go public with our API, we should be looking into them as well. So that's basically the takeaways that I have for you. And that's the end of my talk now. Hopefully I didn't talk a lot. I'm open to any questions about our experience so far and anything related to that one.
Thanks very much, Matt. Does anyone have any questions for Matt? Feel free to unmute yourself.
Just wanted to ask, thanks for the talk. That's great to see that how you apply this in production. It inspires us all. Yeah, so the question is, how do you build your backend? What do you use in the backend? Like, or do you use any particular framework? Do you use some kind of service to actually generate this GraphQL backend? How do you do that?
So we were using JavaScript, and the library that we used was GraphQL.js, which is the reference implementation of GraphQL basically a specification. At the time that we were using, we were started building GraphQL, there wasn't much options, so we went with GraphQL JS. Today, I wouldn't go with GraphQL JS. There are way better solutions out there, at least for JavaScript that I do. Like Apollo is a great basically solution. We built everything from ground up. The reason is that we were building on top of the legacy stuff, and our legacy database wasn't necessarily in a great shape, so we couldn't really use code generators. So everything was written by ourselves. One thing that I highly recommend is that when building GraphQL servers, try to not couple a lot with the framework. If you are writing in JavaScript, write most of your code in vanilla JavaScript and out of that framework, and just have some plugins that plugs your code to that framework. The reason why, in my opinion, we should do this one with GraphQL is that, generally speaking with any framework, but most importantly with GraphQL is that I think the community is young and there's a lot of innovation happening, but it's still very basically younger than we think. So if you kind of build a GraphQL server on top of a technology and you integrate heavily with that framework, you're kind of stuck with that framework. So you can't really move to the new tools without doing a lot of refactoring. So, and I think that happens in the next couple of years. I remember that Relay, for example, this was a front-end thing, but Relay had a framework at that time was really good. Apollo had a basically framework. It wasn't great, but then Apollo became really good framework and Relay became redundant type of project, and they released a new version of it as well. So yeah, we use GraphQL JS, and I highly recommend to not integrate a lot with libraries and frameworks.
Thank you.
Hey, Matt. Sorry. Can you guys hear me?
Yes.
Yes. All right. Hey, Matt. Thanks for a great talk. I do have a quick question, and this comes from a bit of experience, like building a few GraphQL servers, especially in a case very similar to yours. So a case where there are multiple clients. They were UI clients, so web clients. There's also, say, mobile clients. There's also third-party customer clients. Now, the thing and kind of the beauty of using GraphQL is, especially when I was building GraphQL servers for web clients, is that it was very useful to shift and like lift and shift some of that UI state out of the UI front-end code and moving it back to the server, where I could, wrap, say, some sort of data in a field in GraphQL as a property in GraphQL, and I can just request that property directly from GraphQL. But what I found, especially when you try to build larger GraphQL servers, is that you end up like creating a lot of these properties that might only be like it feels like it's getting very noisy. Like you end up creating so many different types of properties that might not be used a lot. Did you find that to be a problem, especially in your case, because you've got maybe some, I don't know if you did, but did you have properties that were probably created for the UI, web UI, and then other properties that were created just for the mobile app? Or did you guys not find that to be a problem, or did you just not handle it the same way, just keep stuff in the client side?
In our case, one of the principles that we had was that do not introduce anything that is not generic and it's specific. So we did not have that problem. However, we had a quite similar problem, is that we on the like a side, it's an event-oriented architecture. So different area of our platform, they generate different events. And those events have different shape, like the payload of that event has a different data in it. For example, when a new tenant sign ups, we create an event. When we create this event, for example, say that the tenant app creates that event. It sends that event to GraphQL and GraphQL stores it. So we generate a lot of events with different shapes. We did not, we thought about creating types for each of those events, but then exactly had same problem. It's like, oh, we're gonna have 300 different types, and each of them is used for specific cases. What we've done is that we started doing a little bit of polymorphism in terms of typing in GraphQL, which is kind of against GraphQL's principles. In GraphQL, you have those concrete types, and then you define it. Whereas with our typing system for that specific events is that it's like, instead of saying that, oh, this registration event has a user ID as a device ID, it's like an array of key values. So we try to prevent it that way by having kind of generic types, if I've got that idea. So that's how basically we solve that problem in that case. But I know that this, because it is a type system and you want to annotate things, you ended up having a lot of types, which can be annoying at some point.
Yeah, well, that's a nice idea. Thanks for the answer.
No worries.
Regarding extending the GraphQL API for supporting the various different aspects of the UI and UI state, some GraphQL client-side libraries, such as Apollo Client, have built-in support for layering client-side state over the GraphQL API. So you don't have to have the client state on the back end. You can have it managed on the front end, but it still looks as if it's part of your GraphQL API, but it's managed on the client side. It's worth looking into if you felt that you've been putting client state into your back-end API.
Yeah, that's a great idea. I've noticed that the client-side extensions, which actually that's kind of the route that we've kind of gone down partially, but part of it is also that we're trying to avoid a lot of calculation or compute on the client side, because some of this data is like, it's getting a ton of data down and computing it down to a field or a number. And so we ended up doing it on the server side just for that, but it was only used by one client. But you're right, I just had a look at that, I think a few weeks ago. I think it's fantastic. So thanks for bringing that up.
No worries.